In this demonstration, we're going to look at the effect of light intensity on heating. What I have here is just an old overhead projector. We don't see these as much anymore now that we have the projectors to hook up to our computers. But what I'm going to do is I'm going to take the top off of this. How these work is there's a lens underneath the glass here where the teacher would write that focuses these rays onto this headpiece, and then that would project it out on the wall. And so what I'm going to do is I'm going to take this piece right off, and we're going to use the effect of this lens focusing this light towards a point right about here. So I'm just going to use this piece of paper towel, and as I raise this up, notice we have a certain amount of light here that's illuminating this paper towel. But as I raise this up, that same amount of light is getting concentrated into a smaller area. Until we reach a point up here, we can see that that's much brighter here than it is down here. The light is more intense because it's more concentrated up here, not because there's more light. We have the same amount of light all the way down through, up and down, but because it's concentrated up here near the focal point, it's much brighter, it's much more concentrated. So I'm going to take this other piece of paper towel, and I'm doing the same thing again. I'm going to raise this up and try to hold this right near that focal point. And if we can hold it right in that focal point, because those light rays are so concentrated now in that small area, I don't know if you can see this, but we're starting to get a little bit of smoke produced by this. Now if we held this here long enough, we would singe this paper, maybe even burn a hole in it. Not that we have more light, that light's just concentrated into a smaller area. Now what we're going to do in our next segment is see how does that transfer to heating at the Earth's surface.